In this section, we look at factoring difference of squares. Now, with the difference of squares, our goal is to write our factors in this form, a squared minus b squared, so that we can easily factor them as a minus b, a plus b. And so to do that, we need to keep in mind our perfect squares. Square root of 1, which is 1, square root of 4, which is 2, square root of 9, which is 3, square root of 16, which is 4, square root of 25, which is 5, square root of 36, which is 6, square root of 49, which is 7, square root of 64, which is 8, square root of 81, which is 9, and square root of 100, which is 10. And of course, we can keep going, but those are the main ones that we want to focus on. So what we need to do is take an example like number 1 and rewrite it as a squared minus b squared. So what does that mean? X with the square on the outside, and then we can write 9 with the square on the outside as well. So now our x, our number inside the term inside the parentheses is a, and then 9 would be our b. So if we write this as a minus b, a plus b, our difference of squares is x minus 9, x plus 9. And so that is our goal for all of these examples where we need to factor a difference of squares. In example 2a, we can rewrite 9x squared as 3x to the power of 2, because if you remember, this goes into both of the terms inside. And then we can write 1 to the power of 2. So this factor would be 3x minus 1, 3x plus 1. On this side, we would write this as 6a to the power of 2, 7b to the power of 2. So our factors here are 6a minus 7b, 6a plus 7b. And then we have, in the end over here, p to the power of 2. And we have a fraction, but if you notice, they're both perfect squares. So we can just write this as 5 over 6 to the power of 2. Because when we have a fraction, the exponent goes into both parts of the fraction. So this is p minus 5 over 6, p plus 5 over 6. Now, when we have examples like 3 here, we have p to the power of 4 minus q to the power of 10. Now, this one's a little unique because we don't exactly have a square here. But if you remember our laws of exponents, whenever we separate exponents by a parentheses, we are multiplying. So if we just take that concept, we can rewrite this as p squared to the power of 2, because 2 times 2 would give us 4. And then we can rewrite this as q to the power of, or q to the 5th power to the power of 2. And now we have something that we can factor out. So p squared minus q to the power of 5 and p squared plus q to the power of 5.